好，同学，我们要进行第16周的课程哈。那如同上面所示，今天是 Anomaly Detection。那同样会分两个部分哈，就是 Paper Reading 跟我们会把上礼拜没有讲完的 code review 一下，那还有这个礼拜的 code。那主要是跟这个一样是跟 Anomaly Detection 有关系的哈。那一样哈，就是这堂课，因为15、16周上次礼拜讲过哈，就是它是比较新的内容哈，就是我们有做一些修订，所以我们还是会用英文的方式来 present 今天的课程。那中间还是一样会穿插一些中文的解释哈，如果觉得它比较困难的话。好，那我们就开始今天的课程哦，一样是3个小时，会分3个影片哈。Okay, let's start today's class. Okay, this is our 16th week of this course. So today's topic is anomaly detection, and of course, we will finish the unfinished code last week, and we have some paper readings today, and I will introduce a very important and I think it's a very basic paper of anomaly detection, especially tell you what is exactly anomaly detection is and how do we deal it with using different concept. And we'll do code review today as well. There's some codes that we do not finish last week. We will finish it today. Okay, so first, please take a look at the first paper, which is Anomaly Detection, a Survey. It is published in ACM Computing Survey, which is a very nice journal. It tells us most of the things that we need to know about anomaly detection. Although it was published in 2009, but I think the concept is quite general and universal, so we can it is still very valuable for us to understand what exactly anomaly detection is. So please download the anomaly detection a survey. It is a PDF file, and I make some highlight in the PDF file. So please download it, and maybe you can make some notes on the PDF file. Okay, I think that is the file that I prepared for you. Okay, the title is Anomaly Detection, a Survey. So of course, it talks many things about anomaly detection. Okay, so right here, I would like to go over some highlight I marked. So let's take a look at it. Okay. So the very first thing is anomaly detection, the definition. So it refers to the problem of finding patterns in the data that do not confirm the expected behavior. So basically, as we mentioned, there's a little difference between anomaly detection and intrusion detection. Most of the time, anomaly detection has only one class, which means you have only normal behavior, because the definition of anomaly is deviated from norm. Okay, anomaly means in Mandarin it means 异常嘛，异常就是异于正常嘛，异于正常你要先知道正常才知道什么叫异于正常嘛，哈。So the definition is you have to know what exactly normal behavior or expected behavior is, and you know, and then you design or find some algorithms or some neural networks to help you to know what is the patterns that do not confirm the expected behavior. So that is a definition. So those non-confirming patterns are often referred as anomalies, outliers, exceptions, blah, blah, blah. They are all interchangeable words that represent anomalies. Okay, that's the very first sentence. Okay, so the following is that of course there are several applications that can be are quite suitable for anomaly detection. for example, fraud detections for credit card, insurance, or healthcare, intrusion detections for cybersecurity, fault detection in safety, critical systems, military surveillance for anomaly activities. So basically, you have an idea of normality, right? For example, for fraud detection, you know how the users, how they use credit cards, how they what is their health condition, of course, in normal condition. And then you find something anomaly from their records. For example, if you take the credit card, for example, if you usually, for example, spend $1,000 per month, and then suddenly, and the credit card company received a request for maybe 10,000 credits usage, then it could be viewed as an certain kind of anomaly detection, because you know what is the normal pattern of the user, which is you, to use your credit card. But currently, the new transaction is not what they expected, right? So we can do fraud detection, and so on and so forth. Okay, so the next part is for example, anomalies traffic patterns in a computer network. So as we mentioned before, you can continuously monitor your company, your campus computer network, and try to record what is the normal behavior, normal traffic pattern of your computer network. And if there's any unexpected packets, unexpected traffic volume, which is observed by your monitor, then you can set alarm. You can trigger an alert to alert the network administrator to try to figure out what is the problem of current network. Okay, and anomalous image can be used as an example for anomaly detection as well. For example, you can collect a lot of for example, MRI images, which is from the normal healthy people, and then you maybe you have another anomaly MRI images, which is from some patients. So then you can try to figure out what is the difference between the normal MRI image and the abnormal MRI image, something like that. Okay, so usually we apply several different algorithms to detecting the outliers or anomalies, which we will go over in the next in this hour. Okay, so what are anomalies? So basically, there are several different types of anomalies. Okay, so we take a look at the figure 1. Anomalies are patterns that do not conform to a well-defined notion of normal behavior. So let's take a look at the figure 1. Okay, so the points in N1 and N2, they are clustered, right? They are quite dense. So basically, they are normal points which cluster together. But the data point 01 and 02, they are point anomalies, right? Which is very different from the nodes, the points in N1 and N2. So that's kind of anomaly we call point anomaly. And and O3 is another small clusters, but the size of the cluster is a little bit small. It is a little bit far away from N1 and N2. So O3 of clusters, the points in the cluster O3 can be viewed as anomaly as well. Okay, so there are different types, and point anomalies or anomalies like O3 are considered as anomaly. Okay, there are regions. So there are some other related algorithms or techniques related to anomaly detection. For example, the first one is called noise removal. I think we have introduced some technique about the noise in which we use the digital handwriting in our class, right? So if you apply some noise removal or denoise algorithms such as autoencoder, then they can remove the noise from the original data set. So sometimes noise removal is related to anomaly detection, but it is a little bit different because noise removal is like we remove some noise data point. The noise might be come from the inaccuracy measurement of the data point. For example, the temperature. Okay. For example, the temperature today might be 30 degree today, but your measurement is quite incorrect. So you measure. So the result of your measurement might be 31 degrees today. So the 1 degree is viewed as the noise, but actually the actual value is 30 degrees. So noise removal is trying to remove the on the inaccurate observation from the original dataset. But the anomaly detection is trying to figure out what exactly the data point, which is unexpected. So the concept is a little bit different, but they're related. 好，我们中文再讲一遍，就是noise removal 跟 anomaly detection 是有点差别的哈。比如说我们今天量气温好了，那今天30度，可是你的温度计量出来是31度，那个1度就是 noise， 所以那个 noise 比较像是从原始资料里面你们去筛选出哪些资料是有 noise， 然后你用一些手段把它移掉。那我们曾经教过，像手语数字里面我们教过，比如说 autoencoder 可以移掉一些 noise 啊，因为那些 noise 是比较不重要的资料。那这样子叫做从原始的资料里面去筛出哪些有 noise， 并且 noise 拿掉，所以原始资料就可以校正。这比较属于 noise removal 的范畴，但是 anomaly detection 比较像是一群资料里面你哪一个资料点是你不预期就是 unexpected 的资料，你把它拿掉。这有点不太一样哈。And the second one is called anomaly detection. That means if you have certain if you do have certain data set, okay, data set points, and you make a model to model what exactly the data point represent, right? You have a simplified model. Maybe it is a regression, maybe it is a classification, maybe it's a neural network. No matter what it is, you can model the original dataset points, right? And suddenly there exists a data point which you have never seen before, and then we said it is a novelty. Okay, it is related to anomaly detection, but the application is a little bit different because you have never seen such kind of data set. Okay. Okay, 1.2 challenges. Okay, the challenges of anomaly detection. There are several different points right here, right? I think the very important and the most difficult thing is that you have to define a region representing normal behavior and declare any observation in the data that does not belong to this normal region as anomaly. But some application is not quite fit into this kind of definition. Okay, as we mentioned before, for some application, there's always new data point in the application, in such kind of in one of the application, and every time you see such kind of a new data point, it does not necessarily means it is an anomaly. It is just something new that you have never seen before, but it does not mean it is an anomaly. So so when you want to apply anomaly detection on some application, you have to make sure the definition right here is quite fit into your application. Okay, the challenge is right here. So defining a normal region is quite complex and quite it is a challenging word. Okay, and defining normal behavior is difficult. Sometimes normal behavior keeps evolving. For example, the network bandwidth. Okay, maybe 1 year ago, using certain amount of network, maybe you don't have, for example, maybe 1 year ago you don't you did not subscribe YouTube or Netflix, such kind of multimedia channels. So your network traffic, the amount of network traffic on the average is quite low. But after you apply such kind of services, your network traffic amount may increase, right? Because you watch a lot of videos, movies from the internet, right? So normal behavior keeps evolving, keeps changing. So it will be better that you examine your normal behavior regularly, right? OK，中文是说，有的时候所谓的 normal behavior 是会慢慢改变的。好，比如说我刚刚举的例子是说，比如说你1年前你没有 subscribe Netflix 嘛，所以你家里网络流量就很低嘛。可是，一旦你 subscribe 的这个 Netflix 之后，你网络流量就会变高嘛，对不对？那比如说你要设置一个 intrusion detection system， 看你家有没有遭受攻击，可是你家上传下载的流量就越来越频繁，越频繁，那是因为你的 normal behavior 改变了嘛，对不对？所以比较好的建议是，如果你是做 anomaly detection 的话，你的 model， 你的 normal model 必须要比较 regularly 比较长的在修正跟转换。当然，这个也会造成一个问题，就是说骇客也知道这件事情，所以骇客有的时候也会慢慢的，如果他想要攻击你的话，用网络，他会慢慢的增加它的流量，让你在做这个 normal behavior 的时候看不出来已经有一些慢慢的流量在改变你的 normal behavior， 这也是有可能的。Okay. The first point is that in medical domain, okay, usually a small deviation from normal might be an anomaly. Okay, it's really depend on the application, but for medical domain, the observation is that some disease they start from a very small variant. Okay, from the normal. So you have to set a relatively smaller threshold to define what is the deviation from your normal model. 好，那中文意思是说，有些 application 它比较精细一点，像医学的哈，就是说你的生病是渐渐开始的嘛，对不对？所以有时候你的肿瘤可能一开始很小，所以它的那个deviation 啊，就是那个异常啊，可能会一开始比较小，比较难发现，所以你的 threshold 的设定就比较难以拿捏了。这也是 challenge 之一啦。OK， OK， the next one is availability of labeled data, which means when we do training or validation or testing, especially training and validation, maybe we don't have correct or even we don't have label data available. So it is very difficult for us to do the further analysis. And the next one is the noise, which we mentioned before. Sometimes the collect data has noise, so the label may be incorrect. The features may be incorrect, which might be very annoying when you analyze such kind of data. Okay. So we skip the relative and contribution. Let's see. There are some different aspects of an anomaly detection problem. Okay. So the first one is, of course, for anomaly detection, we like to build normal model, right? So we have a collection of data instance. Okay. Those data can be referred as object records, point vector, patterns, event cases, which is okay because they're interchangeable. Okay, we have a lot of data instance. Okay, and for each data point, we have a set of attributes, which is x1, x2 to xn, as we mentioned before. They are also referred as variables, characteristics, features, dimensions, fields, right? And they can be either binary features, categorical features, or continuous features. Okay. Sometimes binary data, categorical data, or continuous data, they can be transformed to continuous data or categorical data, right? We have showed it before. Okay. Most of the time, important things is that some complex data they can be sequential data, spatial data, or graphic data. Okay, we'll talk about how to deal with different kind of data later. Okay, so for sequence data, we have mentioned before in our previous class. Okay, we have time series data, we have sequence data, something like that. Okay, traffic data, weather data, climate data, they all belong to sequential data or time series data. Okay, and here that's quite important that to do such kind of to do different types of anomaly, to detect different kind of anomaly. First one is called point anomalies. Okay, simply just as what you see in the figure 1, point 01 and 02 and 03, they are point anomaly. They itself are far away from the normal behavior, from the normal model. So if 01, 02, or 03 exist in your dataset, we can find them comparing with the normal model we have. Okay, just as what we see, just as the example I mentioned, the credit card fraud detection. Okay, your transaction of credit card, that you have a normal pattern, right? Right, but suddenly there's a new transaction being requested by certain store, but the amount, the time the transaction issued, the amount that the transaction would like to acquire, they're quite far away from your normal behavior pattern. So you can directly know that transaction, that point, okay, is anomaly. That is what we call point anomalies. It is relatively easier to detect such kind of anomaly, right? But here we have another type of anomaly which is called contextual anomalies. It means the data instance is not in a specific context. Okay, let's take a look. I think the example is quite clear. So let's take a look at figure 3. Okay, here is some. I think that is a temperature measurement for different months, right? For different months, and you can see that there is a trend, right? In summer, the temperature is higher. In winter, the temperature is lower. But you can see that at T2, time 2, okay, there is a point right there. Right, there's a point right there. But it is, I think it is June, right? When you look at T2, this data point, okay, you think about one thing. The temperature range is from the lower plate, from some certain, maybe for example 10 degree. The higher point is maybe 35 degree. Okay, so the range of the temperature is between 10 to 35. Okay, maybe the range is right. Is that. So T2 is the temperature at T2. Is it in the correct range? The answer is yes, it is in the correct range. But this kind of for if you take a look at this figure, if you use the concept of point anomaly, or what we call point anomalies, right? Then T2 is totally okay, because in the entire measurement. T2 is in the range of the lowest temperature to the highest temperature. So T2 is quite okay from the perspective of point anomaly. But T2, it is a time series, right? So T2, it is the T2 is at June, right? So from the context, it should be some temperature, maybe between 28 to 35. So such kind of low temperature should not exist between May and July. So that is the context. The context is the current data point is June. So it should not quite low as you seen in the figure. Okay, so let's go back here. So the data instance is okay because the T2 is still in the range between 10 degree to 35 degree. But under specific context, which is June, the data should not be like this. So that's what we call contextual attribute. And most of the time, spatial data or time series data exists certain kind of contextual anomalies. Okay, so for point anomaly, it is okay if you use certain classification or clustering algorithms such as SVM, neural network, to detect such kind of point anomaly. But for contextual anomalies, it would be better for you to use certain neural networks such as recurrent neural network, such as transformer, or some neural networks that can deal with sequence. For example, RN or CNA, sometimes CNA is good enough to deal with such kind of anomaly. Okay, so that is called contextual anomaly. Okay, the third kind of anomaly is called collective anomalies. Okay, the definition is that if a collection of related data instance is anomalous with respect to the entire data set. Okay, let's take a look at figure 4. I think that is more easier for you to understand the concept. Okay, collective anomaly. That is an that is an human electrocardiogram output, 就是人类的心电图. And you can see that there is a certain anomaly, okay, right there. So compare with the entire data set, entire time series, you can see there is one time span which is anomaly. So you have to consider this sequence, this subsequence is a little bit unexpected from the perspective of the entire sequence. Okay, that's called collective anomaly. So usually they are a sequence of actions. Okay. So I think there are three. In this paper, it lists the 3 different detection approach, which is supervised, semi-supervised, and unsupervised. Okay. I would like to spend some time to deal with it. Okay. First is called supervised anomaly detection. Okay. It is very it related to the classification algorithm we told you before. So it has labels instance for normal as well as anomaly classes. But to my opinion, okay, because the definition of the anomaly detections only rely on normal model. So if you have a data set and it can be separated into normal classes and abnormal classes, I would rather to call it as an basic intrusion detection or supervised detection, supervised classification problem, rather than use the word anomaly. Okay, But even if we can use a very general classification algorithm to deal with such kind of data because it has normal and abnormal labels. But there's still two major issues. The first one is usually the anomalous instances are far fewer compared to the normal instance in the training data. So the labels, the data is imbalanced. So there are several different approaches to deal with imbalanced data. Okay, we will go over some trick, I think in the next hour to help you to understand how to deal with imbalanced data without doing upsampling and downsampling. So there's a trick. Okay, so so if you classify such kind of problem, which is only have filter anomalies data and has tons of normal instance data into supervised anomaly detection, which is okay, but I don't think it is we don't call it, from my opinion, I don't call it anomaly detection. Okay, you have several different approach of imbalance try to deal with imbalanced data. Okay, the second part is, since you have only filter anomaly instance, so the accuracy of the label, especially on anomalous instance, that will be quite important. But however, sometimes we don't have time, we don't have such kind of high quality anomalous labels on the anomalous instance. So sometimes we take a trick again. Okay, some technique has been proposed to inject artificial anomalies into normal data, so that we could have a high quality artificial anomalies. That means you can collect a lot of normal data. Okay, so they're real data, but you don't have anomalous data. So then you create the anomalous data artificially based on some rules in your mind. And you create those data and inject them into your normal data and try to design or apply some algorithm to try to figure out which part is anomaly, which part is normal, and try to build a normal model to to find out those artificially injected anomalous data. So you can do some experiment. How many injected artificial anomaly data point that your algorithm can figure out? So that's one of the way we prove that your normal model, your algorithm is good enough to represent the normal data and can find out the injected artificial anomalies. OK，中文的意思是说，有的时候我们会这个概念比较特别哈，就是说我们有时候在收集资料的时候，基本上只能收集到 normal data， 很难收集到 abnormal data。所以在做实验的时候啊，我们有时候就是人工的去 inject 一些你自己制造出来的 anomaly data 到 normal 的 dataset 里面去。那你可以发展你的 algorithm 去做 normal model， 然后去做 anomaly detection， 看有多少比例的这种人工做出来的 anomaly data 被你找出来。那如果你能够找到很高，比如说你 inject 100个 anomaly 的点到你的 normal dataset 里面去，然后你已经找出了99个，那就很棒嘛，表示说你这个演算法是可以的。那将来有可能真的 anomaly 来的时候，你也可以找到它们。那当然这是一个推论啊，但是有可能。那有很多人是这样做的，因为在正式世界里面收集到那些 anomalies 不太可能，所以这是一种不错的方法。Okay, so that is the supervised anomaly detection. Okay, it's the very first one approach that we may use. Okay, the second one is called semi-supervised anomaly detection. Okay, the assumption is that the training data has labeled instance, but we have only normal class. So for this part, it is relatively to fit in the definition in my mind, which means we have only normal classes. Okay, so with that, so we can build a model for the normal behavior and use this model to identify anomalies in the test data. Okay, that is the actual anomaly detection approaches. Okay, so third one is called unsupervised anomaly detection. Okay, that means since it is unsupervised, so we do not require any training data. Okay, the technique in this category makes it implicit assumption that normal instances are far more frequently than abnormal days in the testing data. So so in this case, we don't have labels. We just have a bunch of data, a lot of data points. We don't know which one is normal, which one is abnormal. But the assumption is that we know in this data set, the normal ones, the normal instance, okay, are far more frequently than the anomalies. So we can apply several different algorithms, such as clustering, such as for let's take an example of cluster. So since the normal has more frequently than the anomalies, right? So we can do clustering. So basically, the clustering will cluster those normal instances because they are relatively frequent in the data point in this data set. So some other small clusters or data points which cannot be clustered with the larger instance, they might be viewed as the anomalies. Okay. That is okay. And for anomaly detection, there are usually several different output. For example, the scores. Okay, given an event or a sequence or a data point, we can output a value between 0 and 1. Okay, and it specifies how malicious that instance is. If it is very malicious, then we can output, for example, 1. If it is a normal data set or a normal data point, we can output 0. So when we do training, we can prepare two data set. One is for anomaly data set, the other is normal data set, and we can do regression, right? When we do regression, we let our neural network to output one single value between 0 and 1. Since it is between 0 and 1, and you can use, for example, a sigmoid function at the end of your neural network, so it can output the value between 0 and 1. Okay, the other one is called is labels. You can simply just output two class, right? One is normal, the other is anomaly. Okay, so you can apply, for example, your network can has two output. The first is the probability of normal. The second one is the probability of anomalous, and you can use softmax. So it depends on what kind of output you would like to use, and they all have corresponding neural network structures. Okay, scores, you output one value, so you can use a sigmoid value on a single output. Labels, you have two labels or even three labels. For labels, you can use the softmax at the end of your layer, at the last layer, so you can output the probability of your different categoric label, right? Okay. Okay, I would like to talk about some applications used of using anomaly detection. The first one is quite simple. It's called intrusion detection. As we mentioned before, we have several data sets, such as packet, such as the PE files, such as the text log files we can use. Okay, so those security administrator may use a neural network, okay, to model the normal behavior and to collect all those data traces from network, from PE files, from logs, to differentiate, to figure out if there's any intrusion in the system. Okay, so there's a very old paper which is written by Denning. It says we have host space or network, but host space intrusion detection is quite easy because we can set up some monitors in your operating system, so it can inspect, it can keep tracking, or it can collect a lot of events or system log, okay, or the execution trace of your program, to use them as the sequences. And you can use the anomaly detection to help you find out which subsequences in the traces are viewed as the deviation of the normal behavior, normal model. Okay, I would like to show you one of the important I would like to show you one of the important paper which describe okay, let me okay. Here is a paper called "The Sense of Salesforce Unix Process." Okay, when your application has been executed in your operating system, okay, usually the process will try to communicate with the operating system by using system calls. Okay, that is a very specific terms called system calls. When your process want to communicate with the operating system, the process need to issue system call so that the operating system knows what to do. Okay, so basically in this paper, very interesting paper, they collect the system call sequences made by certain applications, and of course in the first place they collect a lot of normal program and collect the normal system calls issued by those normal programs, something like that. I think I can. Okay, I think that's it. Okay, so so the author of this paper used the system call sequences as the normal behavior of these normal programs. Okay, and there's an assumption that if the normal program has been hacked by hackers, and those programs will issue certain system calls or system call sequence that have never been observed before, so that as an intrusion detection system, we can monitor the system calls executed by the programs and compare the observed sequences with the normal sequences we observed before, we collected before, and see if there's any deviation. If there exists any deviation, then we can claim that the current execution of this program is anomaly, because we observed certain call sequences which has never been observed before, and we consider this program has been controlled by the hackers, so they perform certain behaviors, certain events that is not defined in a normal model. So I think that is very interesting and important things is that this paper gave us a very nice and interesting, and it proved that such kind of techniques or anomaly detection assumption is valid. So from that time, a lot of security experts, the way they detect anomaly using such kind of concept, they record something which is normal, okay, for a certain period of time, and they record those data points, and maybe they make a model for these normal behaviors, and then use this normal model to against with the current observation to see if there is any deviation from the normal behavior. So then the anomaly detection is done. Okay, I think that is quite straightforward for you. Okay, so of course your data can be come from network. You can collect packet, so you can extract information, you can extract features from the packets you collect, so you can make a normal model for this network. So once the attack launch it, and you can compare it with the normal model. Okay, fraud detection is quite easy. Okay, you have several ways to do fraud detections. Credit detection is the same. Okay, phone fraud, so on and so forth. Insurance claim. Okay, those are all the applications which rely on the concept of anomaly detection. Okay, medical. Okay, I'd like to say something more about the industry detection. Okay, if you have a machine, okay, which makes some products, okay, and you can take a picture of the product it produces, okay. So for the quality control, you can take some pictures of the normal product, right, and make a model of this product. And sometimes, you know, there are some bad products or some product which is not correctly produced. So the pictures of the bad product might be a little different from the normal ones. So you can make a model to do such kind of comparison so that you can know, okay, this product is not correctly produced, so we can remove it from the production line. Okay, the idea is all the same. So there are some applications right here. Okay, image processing is the same. We can use the pictures. We can use the MRI images. We can as we told you before. We can use an image to represent the P files, right? We have done this homework before, and we can use such kind of images to, and we can use, for example, convolutional neural network or recurrent neural network to analyze such kind of sequence data. Okay, text data. we will go over several different codes next hour. They're all specifically related to text-based data. Okay, so on and so forth. Okay, so I think that is that's the figure I'd like to show you. Okay, you can say that in figure 8 at the left hand side, there are several normal classes and there are several anomalies between the normal classes. So basically, you can use a very simple cluster algorithm to cluster the normal class, right? And try to figure out if there is a boundary of your normal classes. And every data point which is far away from your boundary, which is the anomalies. That's one of the anomalies you can do. The other side is called one class anomaly detection, is that you can collect a bunch of normal instance and draw a boundary of this normal normal instance. And if there is any anomalies data point which is far away from the one class classifier, and you say, okay, that is not the normal data point. Okay, the figure you see right here is only 2-dimensional, right? So basically you can use autoencoder, variation autoencoder, every different kind of encoders to transform your original data into a more smaller size of latent space. And you can do the cluster, you can do the boundary, you draw the boundary in the latent space rather than using the original space, which is more complex. So usually the latent space is more clean, it's more dense. So you can do that in your latent space, not in your original space. Okay, so that's called multi-class or one-class classification. Okay, so basically, I think that is all the things I would like to share with you. Of course, there are some other details right here, but I think you can read those text by yourself. Okay, so I think that that's the first hour that I would like to share with you. That is the definition, some concept of anomaly detection. So we'll go. So we will stop right here, and you can see that we have several codes like basic text, like a basic text classifier, text classification with RN, classifier text with BERT, and there's some other one below under anomaly detection, which is classification imbalanced data. We'll go over all those codes in the next 2 hours. Okay, so you can click those links and maybe you can download the code, or you can open it in your code lab. Okay, so that would be the material in the next 2 hours. Okay. Okay, we stop here. Please come back at 10 minutes. Okay, 10 minutes later. Okay.